Hello everyone, I welcome you all to Startup Academy. This is an online gateway to your success in ISS exam. This academy is exclusively for ISS and we have been covering the topic sampling techniques. So, in sampling techniques, in the previous lecture, we started with the topic uh, uh, probability proportional to size, or we can say that varying probability sampling, in which we have started PPS WR. To conduct PPS WR, we have two methods: cumulative total sum and Lehre's method. Yesterday we discussed about cumulative total sum and its disadvantage. Its disadvantage is that we cannot calculate cumulative total sum for all of them. It would be tedious for a large sample size. So for that we use Lehre's method. Today we'll discuss about Lehre's method to overcome the to overcome the disadvantage of cumulative total sum. A new method was introduced, which is Lehre's method. In this method, what do we do? Suppose we have to select a random number m, which is maximum of I goes from 1 to n xi, which is maximum of all the units which have been given to us in the form of xi or auxiliary variable. Firstly, we'll just select this in from the sample, that is maximum of the sizes of n units in the population. That is maximum in the sizes of all units in the population. This is our step 1. Now step 2 is select a pair of random numbers I, j, where I goes from 1 to capital M and j goes from 1 to capital M. Right? Now the third one is if j is less than equal to m, then ith unit is accepted, otherwise it is rejected. Just note down the points or the steps. These are helpful for the examination. Then when we'll do the example, you will be clear with all the steps. Just right now note down the steps. Here it is. Then fourth step is repeat the procedure until n sample units are obtained. So the first is we have to select a number m which is maximum of all the sizes given in the population. Then we'll select a pair of random number I comma j where I goes from 1 to capital N, which is the sample, which is the population size, and j goes from 1 to capital M, which is the m that we calculated in the first step. Then the third step is if j is less than equal to xi, then the ith unit is accepted, otherwise the ith unit which we have selected is rejected. Then we have to repeat the procedure up till n times so that we can get the value of small n sample size. Now moving on further, how do we know that this probability, this method is an example of varying probability? To show that the probability of selection of units are varying and proportional to size. Suppose probability of selection of ith unit in a trial. So it can be denoted by probability that I goes from 1 to capital N and probability that j goes from 1 to capital M given I. This probability can be written as 1 upon n into xi upon m. So let us denote it as P star, say. And the probability that no unit is selected in a trial is given by probability of 1 upon n into summation I goes from 1 to capital N 1 minus xi upon m. So if we multiply this summation, we take this summation inside, we will be getting n minus nx bar. Summation summation I goes from 1 to n, xi is nothing but nx bar upon m. Taking n common and cancelling, we will be getting 1 minus x bar upon m, which let us say which is equals to q. Then the probability that unit is I is selected at a given draw and all the previous draw result in non-selection of unit I. Probability that a unit I is selected at a draw and the previous probability includes non-selection of the unit. So it is given by, first is P star, that it is selected at first draw, then it is not selected at first draw, then it is selected second draw, plus it is not selected at first row and second row, then it is selected at third row. Then it is not selected at first, second, and third row. It is selected at fourth row, and so on. So the sum of it is given by, this is a GP, so it will be given by P star upon 1 minus Q. Now the value of P star was xi upon nm, and the value of 1 minus Q will be x bar upon m. If we minus 1, then 1 and 1 will be cancelled. So here m and m are cancelled, and we are left with xi upon n x bar. It can be written as xi upon x total, which is directly proportional to the size I. And hence we can say that we have proved that this is the case of varying probability and probability proportional to size. So this has been asked in both the cases, in this one as well, in Lahiri's method as well, and in cumulative total sum as well, that we have to prove that these are the these are the processes of varying probability and probability proportional to size. So this is how you will prove it. Now there are certain advantages and disadvantages of this method as well. So first of all, we'll do advantages and disadvantages as well. So what are the advantages? We need not know all the sizes of all units. Here it is not required that all the sizes of all units, that we should know that, or we can say all the sizes of all units are cumulative totals. The second advantage is that the size of all units need not to be known before. And disadvantage is that, first disadvantage, that if we take out a sample or sample pair I and j, if it is not less than equal to capital M xi, then we'll reject that unit, and it consumes lots of time and effort. So wastage of time and efforts if the pair is not selected, pair which is I comma j is not selected. The second disadvantage is that a draw is ineffective if one of the ineffective random number is selected. A draw becomes if ineffective if any ineffective unit is selected. Right? So these are your advantages and disadvantages, two advantages and two disadvantages that we have discussed. Now moving on to one example on this method, Lahiri's method. So let us take an example where So this is an example of Larry's method. Here we have been given factory number, then number of workers, which is xi or auxiliary variable, then industrial production, which is nothing but capital Y, and then cumulative total of size. So there are 10 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of workers are 2, 5, 10, 4, 7, 12, 3, 4, 11, 6. Industrial production is 30, 60, 12, 6, 8, 13, 4, 17, 13, 8. So now cumulative total of sizes we have to calculate. Cumulative total of sizes xi. So first one will be 2 only. Second one will be, first one will be 2 only. Second one will be 2 plus 5, which is equals to 7. Third one will be 2 plus 5 plus 10, which is equals to 17. Then fourth one will be 2 plus 5 plus 10 plus 4, which will be equal to 21, and so on. If we keep on adding, we'll be getting 33, 36, 40, 51, and 57. 2, 7, 17, 21. Okay. So now first step includes selection of maximum of xi, which is capital M. M is equals to maximum of xi from I goes from 1 to n. So here from all of them, the maximum of xi is nothing but this one, 12. 12 is the maximum of xi. So our maximum of xi is 12. Now we'll select any number where second we have to select a pair I comma j, where I goes from 1 to n and j goes from 1 to capital M. So let us draw a table where the heading is random number, I, random number j, observation, selection of unit. Suppose the first random number that we take, I capital N is nothing but R 10 and capital M is nothing but 12. If I select number 5, then random number J is selected as number 7, because from 1 to 12 any number can be taken. Then our observation would be j is equals to 7, which is less than equal to x3. x3 is 10. Here, x3, it is less than equal to x3, that we can see. So hence we can say that it is, we are comparing it with x5, which is 7 is less than equal to x5, which is equals to 7, and hence we can say that trial is accepted, and our unit that we have taken is y5 for sample unit. If we are taking a sample of size small n, which is equal to 3, then let us take another example, which is random number 4 we have selected, and here random number 10. Let us take 10. So j is equals to 10, which is less than equal to x4. x4 is 4, which is not less than equal to x4, which is equals to 4, and hence we can say that trial is rejected. Let us take another number, which is 7 here, or we can take 8, and here we can take 2. So j is equals to 2, which is less than equal to x8, which is equals to 4, and hence we can say that trial is accepted, and our sample is y8. So with this method you can like this you can find out any number of samples by selection of unit by this method, which is known as Lahiri's method. So this was Lahiri's method, and this completes your probability proportional to size with replacement. Now we'll move on to probability proportional to size without replacement in the next lecture. I hope that we have got all that we have done today, and if not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.